Today, the session is about the big topic is water. And there is with us Professor Daphne Hermosilla. Daphne is a professor in our university, Universidad Politécnica de Madrid, and she developed her research career in the design and implementation of water and wastewater management and treatment technologies, including water reclamation and reuse, and in the production of energy use from waste. She holds, we don't have enough time to do a big introduction to Daphne profile, but we can say that she holds a wide scientific expertise in these fields of research. She has a lot of scientific papers, publications, a contribution to scientific symposia, and her participation in several important related research initiatives and committees. So Daphne is really an expert in this field, and I think that it would be very interesting to listen to her and to know a little bit more about the use of water, the sustainable use of water, and how we can apply it in our campus and also in the cities we live. So Daphne, the floor is yours, and it's a pleasure for me to be here. Thank you very much.
Thank you, Francesca, and thank you for your nice introduction. Okay. As Francesca told you, I'm going to speak about the reuse of water and in the development of more resilient cities, that is really more sustainable cities. We all know that life is not possible without water, and that water is linked to all of the sustainable development goals. Only a brief introduction. I include in all the different slides some reference that you can afterwards review in the net, in internet, if you want more information about the information I include in the slides. And anyway, afterwards, if you want to have more information, you can connect me. Okay, life is not possible without water, and water is linked to all the sustainable development goals. In this case, we are going to speak about sustainable cities and communities, and they are also a sustainable development goal, and they are linked to sustainable agriculture, good health and well-being, clean water and sanitation, affordable and clean energy, responsible consumption and production, climate action, naturally life below water, and life on land. And all of them are related with the development of wastewater infrastructure. And 5 important topics: reuse of water with high quality, and the recovery of water from wastewater and raw materials for cities, for inhabitants, and also for industry and commercial and agricultural application. Reuse water safe of pathogens and to reduce pathogens in water. To recover energy from wastewater, we have a lot of organics that can give us energy, and we can recover it with a proper treatment. And also the reuse of nutrients for wastewater that we can use as biofertilizers. We all know that we have a really important problem of phosphorus in the planet, and also a problem of contamination with nitrogen. We can recover nitrogen and phosphorus. We can use as fertilizers, and to avoid the other industrial processes and the use of chemical fertilizers. And also the reduction of contamination. The effluent without treatment of water produce a really huge contamination that we can solve with a proper treatment. We know that more than 50% of world population lives in cities, and they only cover 3% of the Earth's surface. And moreover, OECD tell us that about in 2050, about 86% of the population will be living in urban areas, probably with more than 1 million inhabitants. What that means? That means that we are going to have problems of urban drought that we are now having in a lot of countries in the world, because we have a high demand of water and a lower water supply. We are living in a scenario of climate change. That means we have a climate variability with, in some cases, lower precipitation of extreme storm events with a snow cover. That means that we have less infiltration, less water in groundwater, less water in reservoirs, less run of surface water, and we have a higher temperature with higher evaporation, higher transpiration, higher population, higher urbanization, more exploitation of water for residential areas, for commercial, for agriculture. And then we need to develop different strategies to solve this problem of urban drought that will be worse in the future. We need to develop awareness on water, flexible, reliable, and integrated urban water supply, to develop efficient water management, efficient water management, and efficient water treatments, research for urban droughts and the problem of urban droughts, and to develop programs for international cooperation that allows us to build up resilient urban areas and the mitigation and adaptation to natural disasters. In the traditional concept, we have water from reservoirs, surface water and groundwater, and after a treatment that could be for drinkable water or for industry or for energy producers, we supply to the different areas of a city and for the use of the people, that is commercial, domestic, industrial, green infrastructures, and energy producers. And in the linear concept, all waters, including rainwater, go to the wastewater treatment plant. And after a treatment that usually is a biological treatment, go again to the reservoirs, surface water, and groundwater. In this concept, we have a sustainable use of water resources with a large-scale treatments that consume a lot of energy and at the end reduce water quality. But in the circular resilient concept of water use that we are trying now to develop in cities, the linear concept will be changed for a circular concept. That means we are going to remove the direct effluents to the wastewater treatment plant, and we are going to develop fit-for-use treatments that can allow us to reuse water and to recover valuables from water, and to give water with a higher quality to reservoirs, surface water, and groundwater, and allow us to maintain the water reservoirs for people in cities in general. In the research nowadays, in general, is focused in 4 main topics. One is the management of rainwater, to come back to the old times when we reuse rainwater. And rainwater is not a water that in centralized system we are going to send to the wastewater treatment plant, and is going to give problems, and is not a valuable water that we can use in cities. We are going to decentralize water circuits in order to try to recover energy and valuables from city, and also water for reuse. In industry, we are going to work in zero water discharge to reuse the water and to recover energy and valuables in the industry and also in the energy producers, and to recover energy and valuables from water. The main topic, one of the main topics I told you before, is the reuse of rainwater. This means that we are going to adapt storm water management. How we can do that? Through sustainable urban drainage system that allow us to mitigate overflows, to recharge aquifers, to reuse water, to reduce water treatment costs, and to improve water quality. How? enhancing natural processes like infiltration, evapotranspiration, filtration, retention, and reuse. Because now in the cities, we have reduced infiltration and evapotranspiration. And we need to increase the infiltration and evapotranspiration of water and to use soil filtration and to reuse and retain water for reuse. How? In decentralized nature-based solutions that increase the diversity of landscape, also produce visual amenity, control temperature, and reduce the heat sensation in cities, and enhance biodiversity. These sustainable urban drainage systems are based in decentralized nature-based solutions, mainly permeable pavements and infiltration and detention basins that allow us to afterwards treat water in green roofs, wetlands, like in this picture, that are based mainly in phytoremediation, filtration, and biological treatment through soils. And we can incorporate other treatments, like in this case, aeration, but we can include filtration, oxidation, and also biological treatments. This is a picture of green roofs. And we also can incorporate other treatments like biofiltration based in phytoremediation and also absorption through the filter of soil, filtration of soils, and biotreatment through the organisms that live in the soil, where the plants are going to live. And also we can incorporate other treatment like oxidation. Here I incorporate you a link to the website of Field Factors, because we are working in a project here in Madrid that has been developed by Field Factors in collaboration with the Municipality of Madrid and also with the Universidad Politécnica of Madrid. And you can see more information about biofilters. This biofilter is in Parque Caído, and you can visit if you walk in the park. And here you can see the different projects, and you have more information about these projects. Sorry. Okay. And what are the main problems of rainwater? Disinfection usually has pathogens, nutrients, and also organics that can come from green infrastructures for phyto treatments and from the waste of the animals and humans that live in the cities, and the removal of contaminants of emerging concern. But they have been advantages, like develop a natural environment, can treat air, the control of temperature, the treatment of water, because rainwater reuse is possible because we will treat it adequately for the future use, reduce noise, and increase biodiversity in the cities. Other of the topics I told you for the development of resilient cities is the development of decentralized water systems, mainly for domestic and commercial waters. We can develop a fit-for-use treatment and to avoid the traditional aerobic biological treatment in wastewater treatment plant that consumes a lot of energy. Then we can segregate brown, gray, and rainwater waters. Gray and rainwater are very easy with the treatments we were speaking about for water reuse, and brown and black give us organics, feces, and urine, and this can give us biogas if we treat it properly in an aerobic treatment, and afterwards we can make compost. That at the end means that we can recover valuables like nitrogen, phosphorus, and metals, and inorganics and organics. For example, this is an example of a decentralized treatment system, and here we can see that we can remove from the urine nitrogen, phosphorus, potassium, and we can create biofertilizers. We can produce biogas and compost, and finally, a water that can be used for reuse. We can improve the anaerobic treatments. Here I give you other link to a Blight project that give you more information about anaerobic treatments and the combination with other treatment that can improve. For example, in this case, microalgae can upgrade the biogas and also allow us to remove the excess of nitrogen and phosphorus that afterwards can produce eutrophication. Industrial water management is other topic of interest for development of resilient cities. Usually industry is linked to cities, and in centralized systems, effluents from industry go to the municipal wastewater treatment plants or to the natural water, waters, like reservoirs, underground water, or surface water. How we can improve the industrial water management? Through development fit-for-use treatments based to reach zero water discharge, water reuse, and also the valorization of valuables, like energy, inorganics, and organics. For example, in this example, we can use water for industry. Usually, for example, in Madrid is potable water. And we have an effluent. This effluent, after a treatment, simple treatment, very quick, like sedimentation, dissolved air flotation, or filtration, can be reused for different use in the industry. And if we want a higher quality water, we can include other treatments for removal of organics, like anaerobic or aerobic. Anaerobic allow us to produce biogas, aerobic not, but allow us to remove the organics and also nitrogen and phosphorus. And we have other quality water that can be used in the industry in other processes that needs higher quality. Afterwards, we have other treatments, advanced treatments on other quite cheap treatments like sedimentation, dissolved air flotation, or filtration, or other more expensive and more advanced treatments like absorption membranes or advanced oxidation that allow us to have a higher quality water for other parts of the industry. And after the treatment, we can have another treatment that allow us to have the same quality that fresh water for the industry, then achieving zero water discharge. Sometimes we only need, in some, for example, paper mills, we only need to supply the water that is lost by evaporation. For example, in this case of a paper mill, we are going to supply only the water that is needed for evaporation. And we are going to recover all the waste, like the inking slag, ceramic, and agriculture, and the water that is going to before going to the wastewater treatment plant is recovered to the industry. And if we send more water for the wastewater treatment plant, we can recover it through other treatments, usually membranes and oxidation, in order to remove inorganics, salts, and pathogens, and can be reused in the mill, trying not to spend our fresh water and potable water resources. And the concentrate can be, again, reused in the wastewater treatment plant. But sometimes we have limits, and a lot of researchers are working, trying to avoid these limits. That then are mainly based in the concentration of inorganics and organics that cannot be removed in the traditional wastewater treatment plant and need advanced treatments. In this case, for example, we have this project is in Madrid, in a paper mill, and in the wastewater treatment plant or Arroyo Culebro, where a treatment of, this is the wastewater treatment plant, the traditional wastewater treatment plant with the different treatments, mainly biological treatment, and afterwards the sedimentation tanks. And they included different treatments based in membranes, ultrafiltration, and reverse osmosis, and afterwards a disinfection. And this water is being used for the water for the industry, they only use recovered water from the wastewater treatment plant. You can see more information in the literature. Other concept for industry is industrial symbiosis. All the water, energy, and the compounds that come with water are not waste, are now raw materials for the rest of the industry. This is the concept of, for example, the first place for industrial symbiosis in Europe, that is in Kalundborg in Denmark, but there are now more examples. Here, for example, we have other in Finland, and they are mainly based in, we have effluents and waste, but they are not waste, they are now raw materials. And as you can see here, more of them are based in the recovery of this waste through anaerobic treatment for the production of biogas and bioenergy, and the recovery of water in general. Now, then, we have not wastewater treatment plants, we have biorefineries. The water from cities must be treated with fit-for-use treatment in a circular way, but sometimes we need to send water to a higher or more centralized wastewater treatment plant. But if we think in that wastewater treatment plant like a biorefinery, we can reuse water for irrigation and industrial water, and also for potable water. For example, in Singapore, water from the wastewater treatment plant is used as potable water for the municipality because they have not available freshwater sources. Now we are going to see the example in general. In Spain, we have the Royal Decree 1620 of 2007 that don't allow the use of recovered water from wastewater treatment plant for drinking purposes, but allow us to use it for industry, like in the example of the paper mill of Madrid, I showed you before, and for irrigation. And probably in the future, all water could be used for drinkable purposes, because really we have enough technologies to make it possible to use for drinkable purposes, as in Singapore. In this process, we recover energy. All the organisms can be transformed to energy, and also the sludge, the bacteria that we use for the treatment of water. And we can recover nitrogen, phosphorus, and also salts, and also other organics that could be interest. And at the end, we reduce pollution. Also, other problem of cities are the cities with low density population, because in these cases, the centralized water system with basic in aerobic treatment are not possible because they consume a lot of energy. Then now a lot of people is developing nature-based solutions based in other treatment that can allow to treat water, avoid the contamination of this water, and to recover valuable resources, like for example, wood, nitrogen, phosphorus, energy. This is the example of Singapore I told you before. They have a really huge problem for having potable water and also water for industry. And previously, they bought the water or they used desalination, and now they have developed the treatment of the water from the wastewater treatment plant. This is called new water, and they use for the supply of population and industry, and also they combine with water, rainwater in the stormwater management. They treat the water and they use also for population and industry. And also they collect the water and they treat again the water like new water. And they convert this in a circle. You have more information here, as I told you before. Then we can change to a circular resilient concept, making the cities more sustainable in the future. Changing this linear concept to other circular concept that allow us to recover energy, valuables, and reuse water, and to have more resilient cities to the events of drought and to extreme climate events. based on management of rainwater, decentralized water circuits, zero water discharge in industry, and the recovery of energy unvaluables. And that's all. Thank you very much for attending this presentation.
Thank you very much, Daphne, for your presentation and also for the time. If there is any questions, you can write it in the chat, or also to open your mic and ask. Well, we will. If there's no question, we want to use the time we still have with Daphne to make some question and to give her the opportunity to speak on some topics that he should summarize a lot because of the time. So Daphne, if you agree, I can ask you some questions, or one question, and you can answer. And if there is more time and someone want to ask, well, we can continue. Thank you. My question was about the implementation of this system. I mean, the use of water in this way, use this of decentralization in cities. If we can implement in a large scale now, if we are ready, if we are ready or not to implement this system in a large scale. Could you explain a little bit about this point, please, Daphne?
Yes, yes, we have the technology to develop this circular system in cities. The main problem is that we have a centralized system, and it's very expensive to change in the actual neighborhoods. To change, we make also the simulation and the economics, for example, in the university, in our School of Engineering, and we need at least 10 years for pay the investment. Then it's better to implement this system probably due to economics in the new neighborhoods. And in some cases it's being developed in the new neighborhoods. It's quite easy when you are making a new neighborhood, a new building, to segregate waters and to leave the system ready for the introduction of treatments like anaerobic treatments, small anaerobic treatment for the generation of biogas in the buildings. But it's very expensive when you have the buildings and everything ready. It's like in the cities. Now it's very difficult to implement sustainable urban drainage system in the actual neighborhoods. But in the new neighborhoods, in the new parks, we can introduce this system. At the end, in the future, we will have more circular and resilient cities.
So we could say that the main limitation to the use of rainwater, to the reuse rainwater in the city is an economic limitation. I mean, we have the technology, but it is very expensive. So this is the main limitation, or are there some other limitations for the reuse of water in cities?
And in the case of rainwater, the treatment is quite simple, because usually this water has not a high contamination, although there are not too much information in the bibliography, and we need more information about the specific contaminants, more related with chemicals of emerging concern, with contaminants of an emerging concern. But anyway, it's not difficult, and we can install biofilters. The main problem is to install proper detention basins and storage places for storage water that are quite expensive, and sometimes we have not enough space in the actual neighborhoods, and also to develop the system to catch the water, to store the water, because in the actual neighborhoods we have not enough space. Mm-hmm. But in the future, probably in the new neighborhoods, we can install sustainable urban drainage systems, and then we can store water in some specific places for reuse. And the treatment is that we have the technology and it's not difficult to implement.
Okay, thank you. And this water we can reuse also for drinking, or which are the main uses that we can have with the rainwater reuse and also wastewater reuse?
It could be used for drinkable water, like people from Singapore is doing, because we have the technology, even for rainwater, that is, the treatment is not so extensive, and for wastewater treatment, because we have the technology available for that. The problem now, for example, in Spain, is legislation. In Spain, we have the royal decree that don't allow to use this water for drinkable purposes, even rainwater, if we reuse that. It's different if we send the water to natural sources or reservoirs. If rainwater go to that, usually we use that water after treatment for drinkable purposes. That's why it's not a real problem. The problem nowadays for direct reuse is regarding the royal decree, but I suppose that in the future this will change, or in the world in general. But in different places like Singapore and also California, they are using this water for, even wastewater from urban treatment plants for drinkable purposes.
Okay, thank you, Daphne. We have 5 minutes more. If there are some questions, Martina.
Yeah, I wanted to ask you about the energy production with urban water waste. Is it feasible, economically feasible?
Yeah, but not in a centralized system. The problem that we have now is that we are missing brown water, that water that came from the urinaries, with gray water, the water that came from the other places of the house and the commercial, water for cleaning hands, etc. This produces a dilution of the organics. With this low amount of organics due to the dilution of the gray water, and sometimes the rainwater, the amount per liter of organics is so low that we have not enough energy, we don't produce enough biogas for being feasible. To produce biogas from urban wastewater treatment plants, we need to segregate brown water from gray water. Then it's feasible and possible. But now for that, we need to change the water circuits of the city. In different places, for example, in Germany, they call green neighborhoods, and they are segregating waters, and they are recovering biogas from the brown waters.
Okay, thank you. Thank you so much.
Okay, thank you. Thank you, Daphne. Are there any more questions from the students that joined us this session? Any curiosity, any idea also, or creative solution? Everything is okay. We are here to talk about and to discuss these topics with you, with our teachers. So don't.
Anyway, you have my email, and if you have some more questions, you can write me an email, and I'm here in the School of Engineering of the Montes of the Universidad Politécnica de Madrid, and you can ask me a question about this if you want. And as I told you, you have a lot of reference and bibliography in the presentation, when you can visit and have more information about the things I was speaking about.
It's nice to see you, or at least to listen to some of you once again, and see you next Wednesday.